Hello, and welcome to my lecture for Calculus BC, Section 8.4, Improper Integrals. I'll start right off with an example because it's easiest to see what these look like from the example. So let's take a look at this example. Oops, that's the graph for the example. So the problem statement is to find the area under y equals e to the x to the left of x equals 1. Okay, so let's graph that and take a look at what it looks like. Okay, so graphing that, you can see that's y equals e to the x from negative infinity up to 1. And you have that area shaded there. That's the area we want to find. See, the difficulty with that is the area extends forever. It just gets really small over to this side. So what we can do is we can write this as an integral going from, I think I actually prefer a different color than that. I can write that as an integral going from negative infinity to 1 of e to the x dx. That's what we call an improper integral, though, because one of the limits of integration is infinite. And so what we needed to do then is we change this into a limit problem, and we change it to a limit as b approaches negative infinity, and then we make the integral from b to 1 of e to the x dx. That seems a little absurd. You could just skip this step, but it's important that you actually show what you're doing and don't just skip it. So please show the step. I'll be looking for it when I'm grading the tests. And so then this, we can take the integral of e to the x. Of course, the integral of e to the x is e to the x. The limit comes on through. So the limit as b approaches negative infinity of e to the x, going from b to 1, and then the limit comes down again as b approaches negative infinity of, plug in the upper limit of integration, or the upper limit, we get e to the 1 minus e to the b. All right, and now if you'll notice, this piece right here, as b approaches negative infinity, e to the negative infinity is approaching 0. So that's approaching 0. So we end up with our problem being equal to e to the 1 minus 0, or just plain old e. All right? So the area under the integral, it's an interesting thing, from e equals negative infinity, from x equals negative infinity to x equals 1 is equal to e. All right, we'll do another example with this video. All right, example 2. And here's another example of a different type of improper integral. In this case, this integral is improper because if you look, it extends from 0 to 1. And at x equals 1, right here, when x approaches 1, 1 minus x is approaching 0. So you end up with a divide by 0 problem right at the edge of your limit of integration. So what we can do is we'll change this to a different integral. But first, let's clean this up. We're going to have to take the integral of this. And the way we do it is to go ahead and rationalize this integral. And so I already did this for us. I'll save us some time. So first of all, we can rewrite it as square root of 1 plus x over square root of 1 minus x. Then if we multiply by square root of 1 plus x over square root of 1 plus x, that will give us square root of 1 plus x, the quantity squared, over square root of 1 minus x squared. And of course, the square root of this thing squared is the absolute value of that thing. All right, so now we need to try to evaluate that. Is that ever negative? Well, for our limits of integration from 0 to 1, 1 plus x is never negative, so we can ignore the absolute value. Then we can break that up by distributing the division to 1 over square root of 1 minus x squared plus x over square root of 1 minus x squared. All right, so with that, we can now rewrite the integral as the integral from 1 to, the integral from 0 to b of this, and you take the limit as b approaches infinity. I had a graph for this thing. Let's see if it shows up in a good spot. Yeah, I kind of wrote on top of it, but see, that's what the integral would look like. And you see, as x approaches infinity, as x approaches 1, the function is approaching infinity. All right, so now we can break this limit up, this integral up, into the two separate integrals. And you notice that this first part is actually just an arcsine. So this ends up being the limit as b approaches 1 of arcsine of x. Just review your notes, make sure you recognize that that is actually arcsine of x. And then this one, we can do u substitution for it. So if we say u is equal to 1 minus x squared, then du is negative 2x dx. So we need a negative 2 here. And if we put a negative 2 here, we need a negative 1/2 on the outside of that. Normally we put it on the outside of the integral, but we have that other integral in the way here. So then this thing ends up being the integral of negative 1/2 of the integral of du over square root of u, or du times u to the negative 1/2. Okay, take the integral of that, we get u to the positive 1/2. We need to multiply by the reciprocal, or divide by 1/2, multiply by 2. So 2 times that negative 1/2 is just a negative 1 times u to the 1/2. And of course our plus c that we'll get later. So then this ends up being minus square root of 1 minus x squared. And there we go. We've got an integral taken. And we can then break this thing up into, or we can actually apply our limits of integration going from 0 to b. We can apply those. So we get arcsine of b minus square root of 1 minus b squared minus arcsine of 0 minus square root of 1 minus 0 squared. We have to take the limit as b approaches 1 of all of that stuff. Okay. Hope we have enough room here. We'll scroll down a little bit, may lose the top, but that's okay. And so now when we take arcsine of 1, all right, that was arcsine. Arcsine of 1 is, of course, pi over 2. Okay, as b approaches 1, this thing's approaching 0, so that's minus 0. Minus arcsine of 0 is 0. And then minus square root of 1. And we end up getting pi over 2 plus 1 as our final answer. All right. Okay, so this video has been going on now for long enough. I think it's time to cut it to the next one. So there'll be a second video of this series. Thank you so much for listening, and make sure to pay attention to the next video.